Hello. What you see in front of you is is a plane with the line JI sticking through it. K is just floating around in the middle of nowhere. H is on the plane. D, G, and F are on the plane. And D, G, and F are all on a line in the plane. I, J intersects through G. Basically, you have a sheet of paper. You have a line stabbing through the paper and a line going across the paper. Stab across. Stab across. Name a plane. Well, whenever I name a plane, I'm going to use the word plane. Don't stab at yourself. Why are you not writing? Because I don't have the pen on. I'll call this plane. You really should use 3 letters to name a plane. So how about H, D, G? That's a plane. I guess I could name a plane like I could say Boeing. Name a line. So many. Somebody in the chat give me 2 points that could be the name of a line. On your mark, set.
D and F.
Never mind. D and F. So I'll say D and F. Make sure you put the little line with the arrows on it. I could do DG. I could do GF. I could do FD. I could do GD. I could do FG. I could do IJ. IG for Instagram. GJ. So many options. So many options I could use. But that's all stuff you learned last week. No funny meme. No funny meme. Just fact. But today we're mainly talking about segments, I think. Mainly segments. Yeah. Line segments and distance. Look at the hipster-looking gentleman on the left. He's got a beard and glasses and nice hair. A portion. What's a line segment, you ask? A line segment is a portion or a piece of a line that allows you to build blah, 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 blah. Essentially, a line segment is a line with endpoints instead of arrows. That's cute. With endpoints instead of arrows. This line segment here, CX, doesn't go on forever. It actually stops somewhere. And then the way we write out CX is, remember in the warm-up we wrote out that DF was a line and we put the arrows attached to it? Here we have a line with no arrows attached to it. So I can call that line segment XC or line segment CX. And again, C and X have endpoints. On the right side here, it's basically saying, look, if I have endpoints, they don't go on forever. I can give them measurements. So between C and G is 7 units. And between G and R are 5 units, and so on and so forth. All right, questions about what a line segment is. Lines go on forever. Line segments don't. That's the difference between the two. So here we go, CD compact disc. It's whenever you see CD with no line above it, that usually means distance. So when it says find each measure and it says CD, and if you're wondering, well, where's the line above? Usually when you're given 2 letters, when you're given 2 letters and there's no line above it, that represents some kind of distance, and so that's why there's no line there. So my job is to find from C to D. Just 1 letter or 1 word is all I need for you to describe how I do this problem. I'll let you guys jump in. How do I do CD? How do I do problem 1? I already have the answer. It is 3.8, and Santiago said you add. That's literally all it is. This is saying find the distance from C to D. C to E is 1.1, and E to D is 2.7. And so all I do is add them Johns. I add them Johns real good, and that gets me 3.8 inches. Problem 2, I'm finding from R to S. Okay, so I'm finding a segment inside a segment. I know the whole segment is 4, And the part that I do know is 1.6 right there. So one word is all I need. Subtract, said Santiago on the chitty chat. So I'm going to do 4 minus 1.6, and that gets me 2.4 centimeters. Easy peasy. I didn't, if I wanted to, I could say, let's let RS be X and X plus 1.6 equals 4. But I think common sense is allowed to take over when we do a problem like this. Super hard, gang? No. It's a little challenging, but don't worry. Videos. Videos will help. Let me turn down my volume so it's not an echo.
Let's talk about lines and such. The directions here are asking us to find X, and then it gives us these letters. AB equals stuff, BC equals stuff, AC equals stuff. What this is implying is that we have a line segment. The 3 letters that I have are A, B, and C, and then AC is 94. So we can assume that there is a line called AC, so we'll put A there, and we'll put C there. And somewhere in between, there's a B. I don't know how long they are, so I'm just going to put a random B there. What I do know is between A and B, I have 4X. In between B and C, I have 2 times the quantity 12 minus X. And the whole thing, the whole shebang, is 94. So what we're allowed to do is we're allowed to say 4x plus 2 parentheses 12 minus x equals 94. Since the letters kind of dictate where things are, I'm allowed to assume that this is just a regular old multi-step equation. So I solve it using distributive property first. 4x plus 2 times 12 is 24. 2 times negative x is negative 2x. Equals 94. 4x and negative 2x combine to make regular 2x. 2x plus 24 equals 94. Minus 24 from both sides. Minus 24 from both sides. 2x equals 70. Divide both sides by 2, and x is going to end up equaling 35. Okay, not 35 inches, just regular old 35, because we were never given a unit in the first place. There you have it.
All right, so what you saw is you were given not a picture at all. That's all right. So the video demonstrates how to do these types of problems, but let's just do some more, and hopefully that'll clear things up for a few of you who are saying, I'm not 100% sure how to do this. So B, C, B, okay, so I have B lives in between C and D. So we'll call this, so I will draw one picture once, just so I have it in front of me. Here's C, here's D. Wow, that is really bad. There's C, there's D, and B lives somewhere in the middle. I need to find the value of X and BC. Okay, okay, I have a picture. There's C, there's D. B is somewhere in the middle. It doesn't really matter because we're not worried about accuracy. CB is 2x. BD is 4x. And BD is 12. Okay, so let's see what we know. This actually is a lot easier. BD is 4x. It also tells us that BD is 12. So if BD is 4x and BD is also 12, can't we just say 4x equals 12? Can't we just say that? Divide both sides by 4. Divide by 4. And x equals 3. I did one part. Part 1 says find x and BC. So I found x and x is 3. I haven't found BC. Remember, BC and CB are the same thing. So it says here that CB is 2x. So if CB is 2x, then CB is 2 times x. And I just found out that x is 3. So CB is 2 times 3, which makes CB the same as 6. Okay. So the picture, not too necessary. I just drew it anyway because why not? I didn't read the problem ahead of time. I just drew it anyway. And the picture wasn't really that necessary. I just took all the information that I had, solved an equation, plugged stuff in. So it seems like I might have the same type of problem, but we'll see. Let me draw my picture again because why not? C, D, and B is somewhere in the middle. Not exactly the middle, just somewhere in between. We'll deal with exactly in the middle tomorrow. CB is 4x minus 9. BD is 3x plus 5. And CD is 17. So what we have is the same exact type of problem from the video that we watched. I have this chunk plus that chunk is going to equal the whole thing. So I can say 4x minus 9 plus 3x plus 5 equals 17. And again, you got to kind of forgive me for my screen not working as well as I wish it would. 4x minus 9 was that piece. 3x plus 5 was that piece. Adding them all up, I get 17. So I have 4x and I have 3x. They combine to make 7x. I have negative 9 and negative 5. They combine to make negative 14. And that equals 17. I add 14 to both sides, which gives me what, 31? 31. No, it doesn't. Yeah, it does. Oh my gosh. I divide everything by 7. And I get 31 over 7 for x. Not pretty at all. I'm supposed to find BC also. BC. Let me, oh, no. Yeah, you know what? I'll reset the page. X was 31 over 7. X was 31 over 7. X was 31 over 7. No, I won't reset the page. Oh, no. Ah. You're right. You guys are absolutely right. I think in writing it out, I completely messed up a plus sign there. You guys are right. Let me quick do that again. These add up 4x minus 9 plus 3x plus 5. I think I accidentally wrote out a minus 5 instead of plus 5. Is that what I did? think that's what I did. Either that or I blame the screen again. All right, so that became 7x. That became minus 4. Add 4 to both sides. Right? Better. Divide by 7. Divide by 7. X is 3. So that's much more pleasant than the ugly problem the ugly fraction that we got. Now when I want to find out CB, okay, I take the fact that CB is 4x minus 9. So CB is 4 times 3 minus 9, which is 12 minus 9, which is 3. All right. Much better. Much better. I'm sorry. Okay. Lots of 3s. See this little symbol right here? That symbol? That means is congruent to. That means equal. If I put a line or 2 dashes or 2 tick marks on lines or whatever, that implies that those lines are equal to each other. Okay? And so I would then say that line segment AB is congruent to line segment CD because both of these have those tick marks, thus and therefore indicating that they're equal to each other. All right. We're not doing constructions because we're not in person. We'll wait to do constructions while we're in person. Don't worry about that. All right. Use the number line to find each measure. This is actually pretty easy. Pretty easy. XY goes from here to here. How long is that line? Type it out or say it.
Mr. Parrish?
Yeah.
Russell just texted me that he has to go and he won't be back today. He didn't tell me for what, but he just said he had to go.
Okay.
Okay.
Thank you. How long is that? Eight and 8. Good. Best way to do this is go from the bigger number and subtract out the smaller numbers. 7 minus -1 is the same thing as 7 plus 1, which is 8. How long is WZ? How long is WZ? Europe? 4.
9.
Easy. Yep, good. 4 minus -5, another double negative. Those of you who play like Madden and stuff like that, this should come pretty easy to you. Those of you who I coached football for a bunch of years, so like this to me makes sense because it's like, oh, I lost 5 yards, but now I made it to the 4-yard line, so I made 9 yards there. So I can visualize that a little bit better. But the other way to do it is the way I exactly showed you. You just kind of write out the numbers, subtract biggest minus smallest, and that'll give you the distance. This is a video you're gonna hate. Here we go.
The distance formula. Nobody likes the distance formula, but we have to do it anyway. There it is. If you think it's very similar to Pythagorean theorem, you're absolutely right. The distance formula comes from the Pythagorean theorem, and the D in this case represents the hypotenuse of a missing triangle. So we're told that we have x sub 2's and x sub 1's and all the same thing with the y's. So what we do first is we label our points x sub 1, y sub 1. x sub 2, y sub 2. It doesn't matter which point you label the 1s and the 2s, as long as you do xy, xy, and as long as you keep the same number on each point. I couldn't do like, x sub 1, y sub 2, or y and x. It's got to be in that order. It just doesn't matter which one your 1s are and which ones your 2s are. Now I plug it into the distance formula. D equals a huge square root. X sub 2, in my case, is -4, so I'm going to plug in -4 minus x sub 1 is 3 squared, plus y sub 2 is 6 minus, and y sub 1 is -1 squared again. And now it's just a matter of doing PEMDAS inside of the square root. I have a giant square root of -4 minus 3, which is -7 squared, plus 6 double negative, which becomes a positive, 1 squared becomes 7 squared. -7 inside parentheses squared is 49. Regular 7 inside parentheses squared is also 49. And 49 plus 49 is 98. Now, I guess you could just throw that into your calculator, but what kind of fun is that? Let's make a factor tree and simplify. I already know that 49 and 49, so why don't I just make 2 and 49? And then I have 7 and 7. So the square root of 98 is the same thing as 2 times 7 times 7. The way you simplify a radical is you look for identical pairs. So I have a pair of 7s, bring that out. And my final answer, my distance, is going to end up being 7 times the square root of 2. Or a little under 10, 9 point something, 9.8 or 9.9 if you throw it into your calculator. But again, that's no fun.
Papel y la pluma. Oh, Russell's back. I thought he left. Distance formula. Gross. Probably in Algebra 1, you were told that you could do a problem like this using Pythagorean theorem, which you could. You could find out that this is 4. How did I do that? 1, 2, 3, 4. And then this is 1, 2, 3. And you can call that C. And 4 squared plus 3 squared equals C squared. But you know what? Boring, boring, boring. We're not in Algebra 1 anymore. We are in Algebra 2. Just kidding. We're in geometry. So let's do this using the distance formula. Just because it's good practice, you're going to have to use the distance formula quite a bit to make these types of problems work out. So I have the points 1, 2, and 5, 5. Actually, I already have them written out. Why don't I just label them over there so I can save myself some space? I'm going to call 1, 2, x sub 1, y sub 1. And I'm going to call 5, 5, x sub 2, y sub 2. Now, what I said in the video is it doesn't matter which point you call your 1s and which point you call your 2s, as long as you have it x, y, and as long as the same numbers are together. You don't want to do x sub 1, y sub 2, or you don't want to do y sub 1, x sub 1, go backwards. It doesn't matter which is which. Now I can plug things in. Okay, x sub 2, according to my point over here, is 5, 5. So x sub 2 is 5 minus x sub 1, which is 1, close parentheses, squared. Plus y sub 2 over there on the blue arrow is 5 minus y sub 1, the dot without an arrow attached to it is 2, close parentheses, squared. Again, this is Pythagorean theorem. And the numbers that I just drew out and erased will show up. 5 minus 1 is 4 squared, plus 5 minus 2 is 3 squared, just like we had before, just like we saw in the triangle that I drew. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. And the square root of 25 is 5. Hey. Okay. 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 And if I did Pythagorean theorem, we would have done 3 squared plus 4 squared, which would have been 9 plus 16, like I did over here. And then we would add them and get 25, like I did here. And then we'd square root 25, like I did right there, and get 5 anyway. Same thing. Ish the same. Is this all we're doing? Okay, yeah. So let's do a couple. Maybe we'll just do 2 of them. We'll see. We'll see how much time we have. We need to end in 12 minutes. So if I can get all 3 of them in 12 minutes, that's great. But I didn't leave myself a whole lot of room. So we'll see. Maybe we'll just do 2 of them. The graduating classes have buried time capsules on the campus of Eastside over 20 years. Great. The points on the diagram show the position of the 3 time capsules. Find the distance between each pair of time capsules. So all that time capsule nonsense is just that nonsense. Let's do 7. Okay. I'm going to label you x sub 1, y sub 1, and I'm going to label you x sub 2, y sub 2. Problem 7 is the distance formula equals big square root, parentheses, x sub 2 minus x sub 1, close parentheses, squared, plus y sub 2 minus y sub 1, close parentheses, squared. So that's the distance formula. All I did was rewrite the distance formula. Okay. 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 That equals a big square root of x sub 2. I labeled x sub 2, 2, minus x sub 1, I labeled 4, squared, plus y sub 2, which I labeled negative 3, minus y sub 1, which I labeled 9, squared. In parentheses, 2 minus 4 is negative 2. Plus minus 3, negative 3, minus 9 is negative 12 squared. Okay, just making sure I did it right. It didn't seem right. 4 plus 144 equals the square root of 148. Now, I'm not going to run to my calculator and find out what the square root of 148 is. So what I'm going to do is I'll go over to the left and make a factor tree for 148. So let me think. 2 and 74. What would that be? 2 and 37. No. Yeah. And 37's prime. So the square root of 148 is the same thing as 2 times 2 times 37. Bring out a pair of 2's. And I end up with 2 root 37. And I'm looking at 8, and the answer's not pretty for 8. I could just see it. I'm looking at 9, and the answer is not pretty for 9. So I think just for time purposes, we're going to have to call it a day. But we did 3 examples of the distance formula where the video was an ugly answer. The problem before this was a nice answer, and we have another ugly answer. And if I were to do 8 and 9, we would get ugly answers just like we got here. Okay? So that ends the day. And if we had time, we would do this problem, but it looks like B and C are closest to each other. I think just common sense, just looking at the picture, we could answer that. But, you know, an A and B would be furthest apart. But we really don't have the time to do those unless you want to do them on your own. I mean, you have the PDF. But that's it. We're going to close down for the day. We're going to end the lesson.